Welcome to our webinar. I see we have a nice attention now, and this is going to be exciting. It is for the first time that COM-IoT and Velodyne do a webinar together. That's great. COM-IoT is such an experienced integrator and have great solutions portfolio, so I look forward to this webinar, and we all hope that it will meet your expectations. Today, you have in total 4 hosts in this webinar. My name is Gabriel, and I'm a Velodyne Marketing Manager for the EMEA region. With me today is Montag from engineering. He will join us at the end of the webinar and contribute to the question and answer session.
Doug here speaking. I'm the Technical Solutions Engineer for EMEA.
Yeah, and we have our friends from COM-IoT. Mohamed, please introduce yourself.
Hello, everyone. This is Mohamed Sadek here from COM-IoT Technologies. I have my colleague Ramy with me. Ramy leads our sales and business development in the region.
Hello, everyone. It's a pleasure to have you in our first webinar with Velodyne.
Yeah, so the 4 of us will be your host today. Let's have a look at today's agenda. We want to start with a brief overview of both companies. And before we delve into any solutions detail, we will look at COM-IoT's portfolio in general and explain what 3D LiDAR makes so ideal for traffic and security applications. Following that, you will see a lot of detailed application examples from COM-IoT. And one remark regarding questions from your side. We take our time to answer your questions. The webinar presentation is planned for around 35-40 minutes. Please consider you cannot contribute via microphone. It's put to mute. So please use the chat function to share your questions. And by the way, in case you have questions about any kind of other LiDAR applications, use cases, which we do not cover directly with this webinar, you're welcome to contact us anytime so we can individually follow up with you. And we will be more than happy to do that. Okay, to start, now a little bit about Velodyne. Just a brief intro. We've been around for quite a long time now. Our founder and owner, David Hall, invented real-time surround view LiDAR systems back in 2005. At that time, LiDAR activities were part of Velodyne Acoustics. And since then, a great success story developed. We started commercial production back in 2007, and we are indeed proud of where we are today. Here you see our global presence. I'm just talking from our Europe office near Frankfurt in Germany. Today, we have an incredible number of customers globally. We are working with most major automotive OEMs as well as in a huge variety of emergent technology sectors. Meanwhile, our company has been inventing, producing, and testing state-of-the-art sensors for more than 13 years. And with our current range of LiDAR products, we do much more than automotive. And I'd like to stress this, it sets us clearly apart in the LiDAR market. Nobody has longer experience, nobody has sold more sensors for so many different industries. Our portfolio of sensors addresses AV and ADAS, robotics, mapping, industrial equipment, machinery, supporting a huge variety of industrial automation tasks, UAV drone platforms, agriculture, and not to forget, security and traffic and smart cities. And with the latter, we are in today's webinar, and I'd like to hand over to Mohamed. And for both of us, like to address that we have a program marketing frame that we call Automated with Velodyne. Here we assemble a lot of keen companies from all kinds of industry under one umbrella, and it's a best of, as you may name it, of use cases of integration experience assembled under the roof of Velodyne. Mohamed, it's your turn, please.
So we are delighted and honored to join Velodyne, the world's largest lidar manufacturer, in this webinar. Velodyne and COM-IoT go back a number of years, and we've worked with their sensors, so we found them to be reliable and amazing technology. So this webinar is an opportunity to share some of our solutions that we have developed using artificial intelligence and technologies, primarily with the LiDAR sensors of Velodyne. COM-IoT is a 3-year-old company specialized in developing AI solutions for smart cities, road and transport services, traffic safety, and security. And today we will touch base on some of these solutions that will address these areas, these markets. We have found them to be in high demand. We have deployed them in multiple projects around the region, and I am confident you will find them very special and unique, and address some of your market's requirements. This slide here shows photographs, snapshots of the solutions that we will be discussing. The first one here on the upper left is what we call HORUS TRC. TRC stands for Total Road Control and is a system that provides a package of traffic safety violation detection as well as road and transport services for the ITS technology systems. ITS is the intelligent transport systems that are more and more tenders are coming out requesting it as of late, and we will discuss this in more details. The picture with the police patrol car here is our smart patrol solution. This is the automated AI-based system that allows a police patrol to automatically detect violations and ensure that they are in control of the road wherever they go. You will also find this quite amazing. Then we have this in the upper right corner, we have our PRT solution. That is a security solution. PRT stands for People Recognition and Tracking. This solution uses sensor fusion, whereby we integrate LiDARs and cameras to identify, count, and track people wherever they go. Think of this as a system that works in government installations, airports, outdoor, indoor, military camps, or anywhere that requires intelligent security. It also has multiple other civilian use cases and applications that we will address as well. And finally, this picture here in the lower left corner is our perimeter protection solution using LiDAR technology. And this addresses one of the most pressing problems of perimeter protection, which is false alarms. Systems that exist in the market today seem to generate a lot of false alarms, whether using cameras or other systems. We have developed this solution and applied it in some of our projects, and you will find this also quite impressive. So that's just a high-level view of the solutions that we will be discussing, and I hope that we can have an interactive session. Feel free to ask questions through chat or at the end of the session, and take our emails and follow up and call us, and we will send you much more information. Finally, we have our YouTube channel. Please feel free to access our YouTube channel. You'll see a lot more interesting videos that demonstrate our solutions. Thank you.
Thank you, Mohamed. I will shortly take over again, and just a few words before we delve into the details of the use cases, just a few words about how Lidar works and what Lidar, 3D Lidar, can contribute to these kind of exciting solutions Mohamed will address. Velodyne Lidar technology uses eye-safe laser beams to create a 3D representation of your environment. Lidar offers strong performance in a wide variety of lighting and weather conditions. A multi-channel Lidar scans its environment with billions of photons per second, 360 degrees, in order to completely see the surrounding world. It highlights objects and makes them recognizable and shows movement. And Lidar can handle object recognition of both stationary and non-stationary objects. The latter is clearly a shortcoming of radar, by the way. Lidar, as its own light source, can even see at night. Allow me a few words regarding cameras versus Lidar. Well, cameras depict the world usually in 2D, means they give a flat representation of the environment. After all, our Lidars represent the world in true 3D, as it is. And cameras fall short in dealing with critical light conditions. They lack the capability for instant object measurement and require much more computer power for advanced evaluations. But while combining both sources, camera and Lidar, you really get together a great team. And one more example to illustrate what Lidar contributes to a suite of sensors. The car on the left, which is equipped with radar and camera only, still has blind spots, while with the car on the right, issues with blind spots or also with angle hazards are non-existing anymore. And another important point. Think about how Lidar is superior to radar. It can accurately identify objects at up to 250 meters or beyond, while even high-resolution radar cannot render objects accurately due to the much poorer resolution. And even more radar can have problems with stationary objects. I love the image example here, so I think it speaks volumes. At Velodyne, we have a full range of sensors which enable a lot of great applications within the fields of security, traffic monitoring, and smart cities. I'd just like to highlight here our most powerful LiDAR sensor we currently have, which is the Alpha Prime. The Alpha Prime, with its 128 laser channels, gives you absolutely outstanding performance and enables a lot of applications. And you will see some details later from Mohamed. And just let's have a quick look here at how the data from an Alpha Prime looks like. So this is a very exciting example from San Francisco area, from freeway, and later you see some scenes from inside in the city. So you see the details here. Look at that van. You see the reflectivity. You clearly recognize the number plates. You get the signals from the traffic lights, from the traffic signs. You see the pedestrians, the two-wheelers here. That's amazing material. You can think of so many scenarios for traffic and security applications that would not be possible without the unsurpassed performance features of sensors like that. So if you would like to learn more about our sensor product line, please reach out to us. I don't want to delve here into details anymore. And at that point, would like to hand over again to Mohamed. And he has now great examples to show.
I will start with ITS, Intelligent Transport System. This is a system that we have been developing on for the past several years. And the image here shows one of the units deployed in a regional country. And as you can see, it's about 5 meters tall, and it has a LiDAR and a bunch of cameras, computers, flashlights, etc. Here is what it does. And I'm just going to go through the features and services that it provides quickly before I share with you the videos. It does, as it is called, total road control of a road that is up to 16 lanes. 8 lanes going north, for example, 8 lanes going south. This deployment here is in the island in the middle of the highway, and it is able to measure the speed of each and every vehicle across all the lanes. It can detect violations of tailgating violation detection. It does accident recording, and this you will find very impressive in case of an accident. It also detects accidents, alerts on accidents, but also records accidents in 3 dimensions using LiDAR. It counts all the vehicles, either per lane or per direction, accurate directional vehicle counting. It classifies vehicles, whether they are large vehicles, such as trucks and buses, or smaller vehicles, and counts them, identifies their lanes as required. It detects shoulder driving violations, wrong way violations. It also provides alerts if the traffic flow reaches a congestion state or if it stops completely. And then it can do that even per lane. Also, in some countries, we have noticed that certain lanes have different speed limits. So the system is capable of setting different speed limits for each and every lane as required. So as you can see, it's a variety of services that address not only traffic safety, but also road and transport services. It also detects and alerts on the presence of debris, identifying the location precisely with GPS, with coordinates, and alerts in real time so that road management can remove the hazard from the road. Here are other pictures of the system as it was being deployed. Here is from another country, from another project in a region where we have deployed it. And basically, most of our solutions are LiDARs, cameras, and computers. That's just the hardware structure. I want to jump to the next slide. Here in this slide, this is a picture of a 16-lane highway. And as you can see, a bird view, this is an actual live test. It demonstrates the vehicles in each direction. Each one is detected, is tracked, and the speed is measured with such accuracy up to 6 fractions of a kilometer per hour. All the vehicles are detected, all the vehicles are tracked, and all the vehicles' speed are measured. But not only that, once you detect and track the object, you can do a lot more. Here we're measuring speed, but you can also measure distances. For tailgating violation, you can count, you can classify, you can move the 3D dimension point cloud video generated by the LiDAR sensor in any way you want to achieve your objectives. This video here shows how accident recording can be valuable. Today, when an accident happens, the authorities come and stop the road, identify the For example, let's see this case here, where we have a truck blocking the view of the existing cameras. Assuming an accident happens behind this truck, there is no way you can have a record or a recording of what exactly happened. But with the LiDAR point cloud recording, we are able to see from a variety of angles, including bird view, we can zoom in and out, up to the accuracy of 1 centimeter to see what exactly happened behind this truck, how the accident took place, which car did what, in what lane, very precisely. And that eliminates the need of taking testimonies from witnesses or blocking the road or accident investigation altogether. This accident detection and accident recording service is unmatched and is a major enhancement to road services and traffic safety. I hope you are all able to see clearly how the three-dimension control of the road is helpful in this objective. Again, this video here is demonstrating how we are able to access the furthest lane, including the shoulder, with the calibrated and synchronized camera LiDAR fusion. We are able to identify each and every vehicle and take the image and video of any violation as required. And here's the dashboard showing how the violations come. They include an image of the violating vehicle, the associated metadata, license plate number, date, timestamp, etc. And all is sent immediately on 4G networks or fiber to the landing servers of the authorities. So the violations are stored, are referred to for analytics purposes. The dashboard is very comprehensive. Here we look at the accurate directional vehicle counting. As I mentioned, we can count vehicles by lane or by direction or anywhere required. And here we're counting lanes 1 to 3 and counting lanes 4 to 6. And as you can see, as cars are passing through those virtual counting zones or gates, the counts are updated accordingly. So vehicle counting is a critical requirement by all road authorities and road services agencies. And that just comes as part of the package and is another demonstration of the power of our solution that is LiDAR based. Tailgating violation, this is fully automated like the rest of them. Here, as we can see, we measure the speed of vehicle 1 and the speed of vehicle 2, the distance between them up to 1 centimeter accuracy, and then through the NTSB formula, we are able to identify a violating vehicle and take a photograph with the calibrated camera of that vehicle, issue a violation, and send it immediately to the landing server of the authorities. Tailgating violation detection, very precise. This slide here shows all the services that our HORUS TRC provides. And as you can see, there's just a collection of services and features that have not been ever produced on the road anywhere that we know of. We have some other services that I will skip for now, but this is a traffic light control. This is in response to some of our customers. It's a very interesting, very impressive solution. But I will briefly mention that it addresses the cases where it changes the light of the traffic light depending on the count of vehicles, so that the light cannot remain red when one direction is empty of cars. Accident prevention is another solution that we have also developed. I'm going to skip it for the interest of time. We'll address it. I'm happy to address it later if you wish. but it's also a very unique solution that depends on LiDAR use. I want to move into the smart patrol. Our solution for smart patrol is called P3, plug and play patrol, because it's so easy to use by police officers. And it is based on LiDAR and camera calibrated and synchronized together, and of course with a computer using the power of the vehicle. These are the functions of our P3 Smart Patrol solution. We enforce speed, 2 lanes on the right, 2 lanes on the left of a moving police patrol on the highway in any direction, whether coming or going. Tailgating violation detection, as we have seen. And then we have distracted driver detection and seatbelt violation detection. Those last 2 services are camera-based, and I have a video that I will share with you towards the end of the session of distracted driver detection. It's an amazing solution. Unfortunately, a big problem nowadays with causing much fatality on the road. People using mobile phones while driving. These are pictures from different police departments around the region where our team were deploying our system. Here, I want to show you this video just to elaborate how the LiDAR technology works in the case of a smart patrol. In the middle of the circle, there is the police car with the equipment on it, with our solution inside of it. And what you're seeing, these boxes are the moving vehicles around the car, the police patrol. And as you can see, every vehicle is detected, is tracked, and the speed of it is measured with up to 6 fractions of a kilometer per hour. That's how we developed our solution. It is important to note that generally speaking, the difference between one artificial intelligence-based solution and another is really the level of accuracy. Many solutions can claim to be doing the same objective, but how accurate is your solution? And in the cases that we're discussing today, accuracy lies heavily on the level of enhanced detection of your object, in this case, the cars. So I want to tell you, it's not a secret, enhancement of detection is an effort that can take years to achieve. So it is not enough to detect your object. It is much more important to detect it and stick with it, track it, stay with your object, don't lose your object. Once you do that, once you are able to detect and track comfortably, you can do wonders. You can count and classify and measure and do a variety of things with your solution. Here is P3 in action. This is a real-life test of a police patrol for one of our deployment. And the officer just presses a button to start the whole system. That's why it's plug and play. And the system gets powered up. The 2 cameras on the right and the left are activated. They're both calibrated with the LiDAR sensor on top of the vehicle, the patrol, the dashboard is powered up. And as you can see here, you see the video showing the point cloud video of the LiDAR, as well as the video feed of the 2 cameras. And you set the speed limit either manually or automatically by GPS system. The car is intelligent enough to know where it is and what street it is and what the speed limit is, assuming there is a database for that by the authorities. And then the whole system works by itself. And if the police patrol turns right or left, it again detects its location and again resets the speed limit. And here are the violating vehicles appearing on the dashboard. For every violation, the system records a picture of the car with its license plate. It also records a few seconds of video of it. And then the dashboard is populated with the metadata from time and date stamp, license plate, and all associated information, street code, street name, the speed limit, etc. And all of this is sent immediately over the air to the landing servers of the authorities, so that but also it helps in preventing accidents, because it allows the police officer to intervene, stop the violating vehicle, and issue warning or provide them with the ticket, or to get them totally out of the road if required, so that you can stop an accident before it happens. As we can see here, where I move the mouse, this white vehicle has a driver without a seat belt, seen by a camera that is looking behind the police patrol. And this picture here below it has a driver that is busy engaged on the phone, distracted driver. So these are also violations that are captured in real time and issued and sent to the authorities immediately. So that's the smart patrol, a solution that has already been successfully tested and deployed in real projects with police authorities in multiple regions. Now, as my colleague and friend Dieter mentioned earlier about radars and lidars, some companies try to use radars in moving police patrols, and they failed miserably. And here is a quote from radars.com. It's a direct quote with the link, and it says that in the case of radar that is operated from a moving police vehicle, the number of bad tickets may be as high as 30%, which means the errors are as high as 30%. Our experience has shown that the failure rate of radars from a moving police patrol actually reaches 60 and 70%, just because it is incapable of performing the same way a LiDAR does. That really covers our traffic safety and road and transport solutions. We talked about HORUS, total road control, the stationary unit, whether in the middle of the road, on the side of the road, or P3. We also talked about the Smart Patrol P3, plug and play patrol. I now want to make a change into the security arena. And when I say security, that was the main driver for us to develop these solutions, iTrack. But as we moved on, we discovered that the same systems have a lot of civilian use cases that I will also basically touch on. iTrack is the name of our platform. It uses lidars and cameras. It has a lot of different functionalities. Depending really on the use case that you have, we will walk through them together. It monitors exits and entrance. It identifies if people are present in a place where they shouldn't and provides instant alerts. Combined with the facial recognition, we have a unique facial recognition system that we believe is probably one of the strongest anywhere. Combined with that, with the synchronized and calibrated and configured camera systems and LiDAR systems, it can identify the people, and then it tracks everybody wherever they go during the covered area. It does accurate directional crowd counting for crowd management and crowd control purposes. It provides heat mapping for traffic density, whether outdoor or indoor or in a room. A lot of these applications we're using in our COVID-19 solution as well. And then iTrack also has the perimeter protection functionality, which you will also find extremely interesting, and eliminates the false alarms that I mentioned earlier. And of course, as all our dashboards, it provides on-demand analytics and on-demand data retrieval. So PRT is people recognition and tracking. And the best way to describe PRT is to see a video of it. So I'm going to share with you, before I do that, I'm going to share with you the foundation of our people detection system, we have seen in road and transport and traffic safety that the primary object was vehicles. We detect vehicles, we track vehicles, and then we classify and count and measure speed and do all sorts of other services. In this case here, whether it's security or workforce management or other civilian use cases or even entertainment, the object is the persons, the people, the human. So we developed Varci, and Varci is our perception system for detecting people and only people and tracking them in an enhanced detection way that we believe is much more superior to other similar systems. And this brief video here will demonstrate this. Let's have a look. What you're seeing here on the screen are people. Everyone is, this is just Lidar work. Everyone is given a unique ID, ID 0, ID 3, 14, 15, 10, number 1, ID 2, etc. What you're looking at here is a virtual gate for counting people in or out. And these are so flexible, you could place them anywhere in any shape. Another virtual gate here for counting people, another one. And then here is a zone also for counting, assuming you have a hall or a room or an area where you have maximum attendance of people. So you are always able to count accurately how many people are inside that zone and send and generate alerts when the number of people reaches a certain threshold. So the main point here is that you have to detect the people, you have to track them, don't lose them, so stick with them. And it's more difficult in the case of people than it is in the case of cars, obviously, because cars are much bigger than people. But I want to show you how accurate this system, Varci, has been developed. So I'm going to play this video. And I want you to generally look at how it all works, how the counting works in the zones and in the gates when people pass and cross. There is a much longer video on our YouTube channel called Varci Full View. It's about 9 minutes. But this one here is a small section of it, but I selected it because I wanted to show you a very particular indication of detection accuracy. So here, let's look at it. Now, we've looked at the counting. You've seen that the gates counted are reflective of the number of people that pass it, the same thing for the zone. But here, I want you to look at this guy here, ID 1, and this guy here, ID 0. One of the biggest problems we have noticed in other similar systems is when people become close together in a crowd, the IDs are lost easily. Let's say people are coming out of the airport, coming out of a movie theater, coming into the whatever, crowd or a protest or whatever, and you're trying to track your person or everybody. Once they get so close together, the IDs are lost because of the lack of enhanced detection, which, like I said, takes an enormous amount of AI work. Here, these people are going to meet and hug. ID 1 and ID 0 will face each other, will hug each other, and then will separate and split from each other. Watch what happens here. The sign of success is if we are able to maintain the ID for each of them as they come into contact and as they part ways from each other. So watch. Pay close attention. ID 1, ID 0, now they're hugging, now they're separating, ID 1 and ID 0. So this is a successful demonstration of probably the highest level of accuracy in detection of human beings by any perception system anywhere. The other systems that use the ID, you find when they separate, everyone has a different ID. This becomes 15 and 27 or 134, whatever. But here we have maintained the IDs of the people. In other words, if we were tracking John and Bob, we will maintain the tracking even if John and Bob has come into a crowd or a close contact, such as an embrace and move on. Let's have a final look at it again so that you can see it one more time. Watch here, they come closer towards each other, they hug, and then they separate ID 0 and ID 1. Now, I want to take you to another video of the PRT solution. I want to set the stage before I turn this video on. This is a mall. This is the entrance to a mall in one of the cities in the region, in a top tourist location where security is absolutely required. This is the location right here, laid out in a map. You have the mall entrance, you have a cafe here, you have a restaurant here, and you have another cafe here. And in between, there is a street that is going north or south called London Street. We have deployed in this section lidars, 3 lidar sensors and 1 camera. The camera is located in this corner here and is focused on the mall entrance, looking at people coming out of the mall. And what we're doing is we're identifying people from a facial recognition database, and if they are on the list, an alert is immediately generated. And we are tracking everyone, and we are demonstrating this tracking precisely with distinct color code for every person on a tracking screen. We're also counting the people going into and out of the mall with a virtual gate like we saw in the previous video. And we're also counting people going north and south on the London street with a virtual gate that does the accurate directional counting on the street itself. Now I'm going to play the video and have a look. We have 3 people here. We have Omar, Mohamed, and Asif. All 3 are on the wanted list. This is part of our testing with the police authorities, and now this project has been fully deployed. But it will show you that assuming that all 3 are on the wanted list, the system, through facial recognition, and this camera is calibrated and synchronized and configured with all 3 lidars, and all 3 lidars are calibrated together to augment the point cloud, so you have a much denser data. And when the whole system works together, this is what happens. Omar comes out, he's recognized immediately by name, alert is fired, he's being tracked on the tracking screen in yellow. The same thing for Mohamed and for Asif, alerts are fired, the tracking for each one of them is shown on the tracking screen. The counting automatically happens on the virtual gates in front of the mall entrance and on the street. And as you can see in the video feed here, the 3 people are moving anywhere in the covered area, and they will continuously be tracked wherever they are. Think of it as a wanted person that is recognized at the airport, and the system recognizes him, fires an alert, and starts tracking that person. The police officer will have an iPad that shows that tracking screen, will know exactly where that person is, and will go straight to that person, whether he moved right, left, upstairs, downstairs, went into the duty-free, sitting at the restaurant, moving by gate 16, wherever that person is. Today, what happens is when a person is recognized in a secured location, the authorities personnel go to where the camera is, because that's all they know. Camera 15 has identified that person. But of course, by the time they get to that location, the person is already gone because he's on the move. So this system here will continuously track that person throughout the entire hall, terminal, whatever, and will provide that in real time on a handheld device for the authorities so that they can go immediately to where the person is, not where the person was. This is people recognition and tracking. We have also discovered that this system applies in workforce management in factories or work locations or industrial zones or oil and gas facilities or offshore locations. In fact, we're working with a major oil company to deploy in an offshore location whereby the database is not composed of wanted people, but the employees. So we recognize and identify the employees in that location, we count them, we track them, and we manage them, and in the case of an emergency, we ensure safe eviction by the accurate directional counting of everybody. So workforce management is another use case of this system. Again, we're applying this system exactly as it is with the additional component of thermal cameras so that we can identify and track and count the people whose temperature are high to contribute to the reduction in the spread of COVID-19 virus and allow for safe and gradual return to work by businesses, work facilities, hotels, hospitals, etc. So this is PRT, part of our iTrack platform, people recognition and tracking. And as you can see here in the lower corner here on the right, we have the traffic density. We have now replaced this with heat mapping because it's more what people are accustomed to. Heat mapping reflects the crowd movement and dynamics throughout the covered area. Dashboard provides historic data, on-demand retrieval, analytics, and a host of other services and features, in addition to, of course, scalability. The system is intelligent enough that if, let's say, John Smith is being tracked today at this location, let's say Terminal 1 at the airport, if John Smith takes the train and goes to Terminal 2, he disappears out of the covered area. When he appears again in Terminal 2 and the system is deployed again there, the system will recognize that this is the same person for which there is a tracking record already historical, either 2 hours earlier or 2 years earlier, and will link the record together of the existing current tracking with the previous tracking record of the same person. This is iTrack PRT. Now we'll move into perimeter protection. That's the last solution that we're sharing. Perimeter protection. As I mentioned, it used to be CCTV. That's the majority of perimeter protection today. But now they started adding analytics to the cameras to detect people. The problem is that these analytics generate a lot of false alarms because of the limitations of the cameras. Cameras are two-dimensional, so when you apply an analytics of two-dimension on a perimeter or a fence or a wall, you will likely have much lesser accuracy in detection. Birds, cats, trees, and other objects will generate alarms in most cases, which we have seen, and the solution, we believe, is LiDAR. Let's have a look how LiDAR, all this is described what I have seen. And in this case, we typically calibrate and synchronize the LiDARs with a PTZ camera so that the PTZ camera can be rotated to point to the intruder location on the fence. And here's a picture when we were doing some testing, and of actual testing made by the actual police department, in fact. So let's have a look here. Here's, I want to just eliminate the.
Mohamed, we have also to keep an eye on the clock, so we are running into a little time problem. So
okay, so I'm going to be very brief. I want to share with you this video. Can you all see the screen?
Yeah.
Okay, so here's the wall that we're protecting, and you'll see the police officer running towards the wall. On the right, you see the point cloud video, and on the left, you see the actual video feed of the camera. And watch here as the officer runs into and climbs. Now the alert is immediately fired and is generated along with all the metadata. Here's an example very quickly of the wall, the point cloud, and the video feed. And as you can see here, the people are moving towards the wall. They begin to climb the wall. The alert is fired, and the camera gets to rotate on the intrusion so that the authorities can know where on the wall this intrusion has happened. I guess that just suffices for, I have, of course, many other videos and materials, but at this point, I think we can stop sharing and give you an opportunity to make any comments or ask any questions. And I would encourage you again to check out our YouTube and reach out to us for more information. Thank you all very much for your good attendance.
Thank you very much, Mohamed. Let's have a look. Mohamed, Ramy, do you see any questions?
Unfortunately not. But we encourage our attendees to just share their questions and thoughts. We'd be gladly happy to answer your questions all.
And it may not be a question that you'd like, but a comment, and feel free to do that. And also feel free to just reach out on LinkedIn or on email, or even call me by phone if that's easier. And let's address anything on your mind.
I would have a question that may be of interest to the audience in general. Mohamed, you showed that nice traffic survey solution. You were able to cover with a sensor a huge amount of traffic lanes. So it was up until 16, I think. How difficult is it to install the system? So once you have, you are out with the turnkey system, what's the installation time? How to handle for police? Is it a very plug and play solution? Can it be set up very quickly? What is your experience with that?
Actual installation is very quick. You'll have to build the unit outside, of course, at a workshop, bring it to the location, the desired location. The rest of the installation is really quick. Just the camera, the computer, turn everything on. The thing that takes time is the configuration and synchronization and calibration of all the devices together. And this will typically take 2 to 3 days of work on site. But once you do that, then you just walk away and let the system work automatically by itself forever. So it requires minimum maintenance. The system is scalable. So the whole configuration and commissioning talks about maybe 2 to 3 days, initial installment in a day, and now you have a system that is up and running, covering your entire highway, providing you with total road control.
That sounds really exciting. Thank you. So it's a very mature system, it appears to me, and it can be used very quickly. Cool.
Thank you. I want to also thank all the attendants, really, for your good listening, and I hope that we have provided you with something of interest, and looking forward to future webinars together with Velodyne.
So everybody seems to be happy for the time being. This is a good sign. Yeah, actually we are through with our short excursion into that exciting world of security and traffic applications. And you really brought it to life, Mohamed. Thank you for that. And I hope we were able to convey, we were able to convey what is possible with solutions like the ones we've described. That's cool.
Thank you. Thank you, Dieter, for all help and support and for this webinar together. And I look forward to more cooperation.
Thank you. Thank you too. What is left now? Actually, we have come to the end of this webinar. So I cannot see the audience, but thank you all for joining our webinar. We do hope we met your expectations, and we really would be glad if you get back to us for further discussion. So do not hesitate. You see our contact data here, and we will be more than happy to help you on from here.
I think we have a question here from Engineer Mohamed Rida. He's asking about the lifetime of the lidars, which is a very good question, and I'll leave Dieter to answer that question.
Okay, general lifetime differs slightly from sensor to sensor, but let me say in overall in total, it's between 50 and 60,000 hours of MTTF. So the sensors have proved to be very robust and are running really long under all the different harsh environmental conditions. Other questions?
I don't see any.
Okay.
I think that's it. Thank you everybody for hearing us, and thank you for joining our webinar. And we're glad that we had you today.
Yeah, also from my side,
Thank
you. Goodbye to all of you. Take care.
Bye-bye.
Bye-bye.